Right, I think we're live. Good evening everybody, welcome to the stream, searching for what remains of Atlas Y4. Because at the moment, this on screen is where it should be. And unless that's it just there, I'm not seeing it. I am suffering this evening with sore eyes from hay fever, so my vision might not be up to normal levels. It might even end up being a very short stream, depending how well these painkillers get on. Go for a really long exposure, just to double check. Hey Chris. Nothing to see at the moment. There's a bit of an anomaly just in that area there, centre screen. But at the moment I can't pull anything away from the background. I've double checked my positioning, and this is the area. I can see a smudge there. I can see a smudge there. That's the only bit I think that could be the comet. No, I didn't. I've not had much TV on at all. I've been resting today because I've had rather a bad bout of hay fever, and my eyes are absolutely killing me at the minute. But I think that's it. I think that's the comet there. I don't know if you can see the smudge on your screens, but from where I'm standing, or from where I'm sitting, that's got to be it. I'm just going to do a 1 minute exposure and see if it brings anything else. Just clear that. Yeah, both those two fragments are they are part of the same one because they're both deforming in the same direction. So I think they're moving together. I might reposition the scope in a minute to get away from this amp glow in this bottom right hand corner. I think that's going to be part of the criteria when I do get a new camera. Oh, can you hear me now, mate? I think my battery went flat on my headset. I've just plugged it into a cable. Am I still working? Yeah, I got movement on my meters, so I think I'm back up. Yeah, I think criteria for a new camera is going to be one with a lot less amp glow, or with built-in coolers. Only just visible. Only just visible. I think we've got two main fragments there. I'll just clear it. At the moment we're doing 150-second exposures, but the tracking on the scope's not that brilliant because we're stretching the stars as well, and it's a little bit blustery, so it's not the most ideal conditions. Yeah, my battery died on my headset. I've just plugged into a cable now. I think that might be something to look at later. Order a fresh battery for this. I've got a studio mic. I should set that up, shouldn't I? And just use my headset for monitoring. Yep, that's definitely two of the main fragments. Well, if they stay that distance apart, they're moving in parallel. Let's see if we can do a 3-minute exposure. It's going to look absolutely gross, a 3-minute exposure, because there's too much movement on the alignment. I've not done a proper alignment. I'm getting lazy. I should do a proper alignment before switching everything on. But I'm not planning on doing any long exposure captures. Not this evening anyway. Oh, if you're still interested in the moon tour, in the discussion section of the YouTube page here on my channel, I've dropped a link to a moon map, high detailed moon map, so you can download that and you can follow along on where we visit. That's right, this one here is slightly larger than that one. Move it out of the way. But the front one is no longer at the front of the Coma. What would be the tail starts in front of the last main element. As you can see there, the front of the Coma is just here. So there may be smaller pieces there still causing the bit of the tail. Right, that was 3 minutes. Let's see if we can clear that. Oh, it's in the discussion section of the channel. If you go to the main channel, when you click on the Urban Astronomy link, you'll see where it says videos. The fourth one along will say discussion. If you click on the discussion, there's a link in there for the detailed moon map. If you get it early, you can familiarise yourself with it, and there's, if you can find the Buzz Aldrin and Armstrong links, there's those points are marked on the map because there was the Apollo 11 landing. So if you can find them, I think that's where we'll start. We'll use that as a reference. Yeah, that's definitely more solid. There's definitely more coma in the front of those. Do you know what? I'm going to try 4 minutes, 240 seconds. Because the tracking is not too bad. 3 minutes and the stars are still pretty round. So the tracking should be pretty reasonable. There you go. Let's have a look, see if the stars are still round. That's reasonably round for a main star, so the tracking's holding on, and they've definitely stretched. So, but we're not picking anything up right at the head of the coma. We're definitely not picking anything up at the head of the coma. Oh right, I'll re-add it in a few seconds. I'm not sure why that is. Just bear with me. I'll go and have a look. Just have a look now. I've just repasted it. See if it's visible to you. I can see small artifacts just here. I wonder if they're the last. Yeah, what's on screen now? I think there's two small pieces there. They might be slightly smaller fragments. I'll move that out of the way. That smudge is what's left of the comet. We're currently doing 4-minute exposures just to pull this up. Tracking's pretty reasonable. The stars are still pretty round. Link's not there. Okay, just bear with me. I'll do it at the end of the stream. It's appearing on my screen. I don't know why it's not appearing on yours. Yeah, that one's stretching pretty consistently, and I think that one is as well. So that front of the coma, I can just see two small pieces there. So I think the larger piece is again left behind, and the smaller ones are staying together with the main body in the main direction of travel. Yes, the Comet's still there, but we're struggling to identify any of the larger elements. Right, right. I'll leave this on screen for a second, and I'll have a look, see if I can post it, see what's the matter with it. Right, I've lost it. Right, just bear with me a second. Yeah, I've dropped another link in, see if that works. But looking at that for a 4-minute exposure, there's still definitely elements of the comet there, but not as distinct as it was from a few days ago when we were trailing it. No, I don't think the comet's going to be that visible. let me just have a look on there. I'll show you a picture that somebody else got, and I was comparing it to what we was actually tracking from the other evening. If I can find it. It was a photograph from Space Weather, and they had quite a high detailed image of it. Well, if you compare that image we've got on screen now to what we got 2 days ago, that's what we had 2 days ago, and this is what we've got right now. And you can definitely see the two main fragments on there. Let me just fill that screen. Yep. From a couple of days ago, you can see the two main elements there, and I think those two elements we've got left on screen now. Move that out of the way. Those two are the same two. Move that out of the way, because that's the smudge of the comet. It'd have to be a really long range missile to get that far. It's still quite a few million miles away. It's 146.4 million kilometers away. Earth distance. 146.4 million kilometers away. So the intensity of the comet is reducing, but we can still just about pick it up from the background, despite all the amp glow from satellite went through there, despite all the amp glow from the non-cooled camera. I'm not sure if they've got a plan of action if they discovered something coming towards the Earth. They've touted the options of warming one side with the laser, just enough for it to gas off and deflect it from its course. So they have thought about it. Whether, I don't think a missile will be a viable option, because if they broke it up into more fragments, we'd have lots of smaller comets or meteorites hitting the planet rather than just one big one. I think both scenarios are not what you'd call desirable. Let's see what this one looks like. It's 228 seconds, we're going close to the 4 minutes. But the stars are pretty round when there's no wind touching the telescope. At 4 minutes the stars are pretty round. Unlike that, I think it's still breezy outside, but that's definitely remnants of the comet. I'm wondering if they're stars now, because they don't seem to be going with the coma. The thing is, if they can see it, and it's far enough away for them to be able to have enough time to put a plan together, the time to target, if you got on, say, the shuttle at its fastest speed, it would still be too close to the Earth to be able to do anything meaningful. They definitely need something a lot faster than what we've got at the moment if they needed to go out to intercept it. Yeah, I mean, what's left of it is very, very, very dim now. I can't. I'm sure those two pieces there are stars, background stars. I don't think it's part of the main comet. That there is the main comet. That there is the main comet. We'd need Elon Musk to get Starship 6 or whatever ready on standby, because they'd need an incredible amount of speed to get close enough to it before it got close enough to us. They'd need to deflect it at a very, very small amount a long way away for it to miss. Right. I'll say they're background stars, because the main comet body there seems to be moving away, and I can't pick any debris up within that Comet Coma. Right, 4 minutes seems to be about the optimum exposure. So what I'm going to do, even though we do get a bit of movement with a bit of wind, I'm going to set a short plan up and do 10 exposures at 4 minutes. That's 240 seconds. Bin one by one. Count 10. Pause 10 seconds. Filter luminance. Update current. Right. I'm going to set up that imaging plan, and then with the next 10 images that it captures, we can step through, see where any movement is. So let me just stop the live view and start the plan. Right, and this will give us an idea of the temperature of the sensor as well when the first exposure comes through. Well, they've got ion drives. They're a lot more efficient, but they don't have the thrust. They can go a lot faster than chemical engines, chemical rocket drives, but it takes them a long time to build up speed. And yeah, that is an issue. Even a small fragment of dust, if it impacts on the vehicle, will literally rip it to pieces. As with the space station, fragments of paint, I think, fragments of dust have come through, and they've gone straight through solar panels and straight through the sides of certain sections of the ship. That's why they've been experimenting with inflatable cabins. Atlas, like it. Right, yeah, I'm 99% sure they're background stars now, and this smudge is all that remains of the comet. There, look. I'm really disappointed now, because I was hoping to find one last evening where I could see a fragment before it all disappeared. But to all intents and purposes, this is all that's left, just the dust. 4 minutes is a really, really long exposure for this camera, as you can see by the amp glow. We'll find out the temperature of the sensor in a short while, coming up in the bottom section just here. Yeah, I can bring up the main page of comets. There's quite a few comets out there. We'll wait till this exposure's come through, and then I'll bring the. In fact, no, I'll do it now while we're waiting. Right, this is the page that I use for picking cometary targets. Starts off with the brightest, easiest ones to find. These are observed magnitude of 7.8. Currently, Atlas now for us is magnitude 9.2, observed magnitude. But I'm not sure when that observation was last taken. But if you look at these individual tiles, when you've got a green telescope there, I mean, because I set the location to where I am, Mansfield, England, UK, Great Britain, it's able to tell me if it's within my horizons, above 30 degrees above the horizon, so I should be able to land on it with my equipment. If it's red, it's below my horizon. And the further away you get from the front of the list, the magnitude drops quite significantly. 13.6, 14.6. Yellow means it's very low, but you might be able to pick it up. Right, let's move this out of the way and have a look what we actually captured on that last shot. Nothing. No, it's overexposed. I thought we'd be pushing it a little bit. Now, stop that plant. I wonder why that came out like that. It shouldn't have done that. No, it's still. I don't think it could be a danger to us. It's still 140 million kilometres away. So even if it's spread out in that sort of a distance, it depends on the fragments. We may get. I wish you could find the three. There's a 3D map that tracks the comet. I wonder if it's on that thing. Let me have a look. And it shows you where it intersects the orbit of Earth. So we'll track it. Oh yes, here we go. Here we go. Back 3D orbit. There we go. Let me just bring this in for you. I'll show you its actual track. Right. There's Atlas. Y4, the comet. Venus, Earth. You can see its trajectory. Earth's over here. So as it gets closer, it should get brighter and brighter and brighter, and then swing by and pass back out again. But it's already breaking up. I don't think there's going to be enough fragments to get close enough to the sun to be bright bright enough to see with the naked eye. I hope that gives you a little bit more of an idea. I can drop the link in for this 3D plan view if you want, if you'd be interested in that. Yeah, just check that link's come through. We'll get you no more exposures or live view. Helps if I press the button. I've always been an atheist. I've only believed in what I can see and what can be proved. So I've never been into religion of any sort. Why are we not getting an image? That's better. I think 4 minutes was way too much. Yeah, I'll just move this out of the way for a minute. You can just about see the smudge there, the remnants of the comet. Right, let's take the exposure back up to 30 seconds. We'll build back up to it. Well, at least we can still find it, but I'm a little bit disappointed as to where the main body's gone, the main fragments have gone. There we go. That's a little bit better view of it, but there's no main body. The skies are pretty clear outside, so if there's anything there, stars are pretty round, so tracking's pretty good. We've lost the main body, and I don't think we're on the wrong target. Now that's got a little bit of something in there. There's a little bit of something there. There's a little bit of a mass at the front of it. as far as tracking goes, if I bring the stellarium in, centralise that. Right. That's where I set it to target, and that's where the scope actually thinks it actually is. So the scope's just a little bit off. So it is the right target and everything. And it's got it listed as a magnitude 10.2 on here. So the magnitude, it is getting dimmer. It is getting a lot dimmer. Right, let's move this back out of the way. I think there's two pieces we can see here still. There's a more concentrated mass there and a slightly more concentrated one there. So out of that, I'd say we've got two pieces. Move that out of the way. Yeah, there's one distinct there, and I think there's one distinct there. So it's looking like there's enough left there for us to keep on, but I'm not sure how much is going to be left tomorrow. The skies are forecast clear again tomorrow evening, and I'll do another follow-up on that. But if we compare what's on screen now to what we got the other day, let's have a look. Compare this to the 15th. There we go. Right. That image there is from the 15th. And this is what we've got this evening. So there's a lot of data that's a lot of density lost, intensity. Let's switch that across there. So there's definitely a lot of it dissipating. Hey Tom, yeah, it's still moving. The image on the left is from the 14th, 15th, when we had that good session. And that's it live this evening, as of about 30 seconds ago. Let me just move this out of the way. There we go. So yeah, there's enough there for us to see, but the main elements of the comet, the body, the core, is nowhere to be seen at the moment. So there's a chance of a collision between debris fields. Now that would be an interesting evening. If you look really closely, I think you can still see parts there, but nothing like what we had a few nights ago. Definitely not as many solid bits there to pull out. Yes, it's definitely gone downhill very, very quickly. See where else I've got from the other evening. Yeah, these are all from last couple of nights, and as you can see, a lot more distinct core elements to look at. Compared to this evening. That's when the breakup first started, the core being stretched, and this is it this evening. So there's definitely some disintegration going off there. And I think that was the 15th, morning of the 15th, about 1 AM in the morning, that. And I seem to remember commenting on that piece there breaking off. And I've seen somebody else's pictures with a 1 meter reflector, space weather telescope I think it was, and they've got two distinct pieces that match that view. I'll move this one off screen so we get back to the main body. Clear. Yeah, you have to tweak the light spectrum to be able to pull it out now. Yeah, you have to manipulate the histogram to get some data. But there's still slight pieces there. If you have a look on that image there, you can see just two slightly denser concentrations of pixels. So I think there's still something there, but it's not as distinct as it used to be. Let's see if we can find that spaceweather.com picture. Here we go. Right, let's see if I can open another picture and put it side by side. Right, let me get these up together, because this is what we got from... not that one. There we go, this is the one. This is our image from the 15th. And that's from the same night. That's what they got with a 90 centimetre reflector, which is significantly larger than our scope that we've got. So that evening, I think we got quite an impressive bit of data for the size of the equipment that we're using. And a side-by-side comparison, everything seems to line up. So I was quite pleased when I saw that. Move them back out off the screen. And looking at that now, on the smaller image there, I'm a bit further away from the screen again. On that smaller image there, I can see two patches. What time we got? 10:30. Right, I'm going to stream till 11 o'clock this evening. I've got an early work shift in the morning. And I've got to drop my daughter off back at university. So I'm going to be up very early in the morning. So yeah, I'll just keep these images coming in for the next half an hour. What these images I've got here at the moment, clearest on YouTube, I'm sure there are other people with a lot better kit and a lot better setups. But I'm quite pleased with what we have got. And for the past, we've had 3 good streams on this Comet, and I've been quite pleased with it. Did you just see the space weather image from the 90cm reflector? I was quite pleased we got a comparable image side by side. Oh, and welcome to the stream, Barra. Yeah, there's no definitive core anymore that I can pick up this evening. No matter how much I manipulate the data. But that one there, there's 2 main elements I can see when I sit back from the screen. I have this tendency to get my nose close up to the screen, and the closer you get, the less you see. Oh, yeah, okay, Chris, thanks very much. I've not, to be honest, I've not looked at other people's. When I'm not streaming, I'm pottering about. I've got to take the main mirror off and give that a clean in a couple of weeks. So that's on the prep list to do. I'll have to have a look. I'll have to have a look at other people's. You're going to give me a complex all this. It's refreshing to know that I can actually accomplish something with my equipment. I think after I finish work tomorrow, before I set up for tomorrow night's stream, I'll have a quick peruse around YouTube and see what other people have got, so I can compare mine to theirs. But at the moment, I've not got nothing distinctive. We can still see the coma and a little bit of tail, but I can't pick out any of the main body, even if I move it out of the way. If I sit back from the screen, I can see a blob there and a blob there, possibly 2 pieces. Well, if you like what you see, like and subscribe. It helps me along, and I'll be more encouraged to go look at the next one that comes along. There's plenty of targets available, and this just happens to be one that I was expecting to last all the way through to the sun. That's why I started streaming early on it, and I just happened to get a couple of shots before it started breaking up, or before other people started breaking up, spotting it breaking up, and I'm glad I stuck with it. And yeah, thanks for that. Now, sitting way back from the screen, I can see an elongated section that could be remnants of its main core. One, two, three pieces. I'd say 3 pieces. I don't know what happened to that 4th piece, the larger piece from the front. I'm giving you a thumbs up, guys. Thanks for the encouragement. Yes, we definitely got a solid element last time. Cheers, mate. Cheers. Yeah. Bring that out. Let's have a look. Yeah, without tweaking the histogram, it's just a blur. Right, I'm just going to change the gain on the camera a little bit, because I know we're on the sweet spot at 250, but things have changed. We might pull a little bit of something different out. Right, let's see what this one's going to do. Too much, but we have the technology. Right, a right stretch. Actually, that has picked something else up. Just there, look. Right at the front, just that bit there. Let's see if I can drag that data across. Yeah, it's actually picked a piece up. Shows what happens when you have a little bit of a play with the buttons. Yeah, I'd say the main body was that area there now. That I'm marking with a cursor. And the rest is just dust gassing off down there. So I'd say the main core is just that smaller bit at the front. I'm beginning to seriously wonder if there'll be very much left for tomorrow evening. Of course, with these settings here, this is right at the limit of what I can expect with my kit. Let's give it a 90. We're on 30 seconds. Let's try 90 seconds. This is going to go way overexposed in a second when that one comes through. We'll see what 1.5 minutes drags out of the background for us. Oh, for those that are going to come along for the moon tour when I do it, if there are any elements you'd like to actually have a look at, drop me a message beforehand, and I'll try and set something up to include in the evening's viewing. Yeah, there's still some solid elements about this, but they're not as distinct as they were the other evening. One of the first things we'll look for is the Apollo 11 landing site, and we'll work our way around from that point. Right, get ready for overexposure. Oh, too much. Clear. Here we go, we've been photobombed. Now, 90 seconds is too much. In fact, I'll drop it back down to 45. Clear that. Depends on the frame rate of the camera. I've been mooching around the moon when I've actually had a satellite go across the view. If you have a look at one of my other streams, I was preparing for Mercury's transit, and an aircraft went right through center screen, and you could see the turbulence from its engines. Yeah, I know, it's a little bit overexposed. That's 90 seconds. Oh dear, too bad, too bad. Right, stop that and then restart it again. Sorry about that. I was expecting it to overexpose, but not by that much. That's because we've got the gain up at 300 again, isn't it? Oh, bulb sector 645 seconds. That might have been why. Right, let's have a look at this again. There she is. She's still there. She's not escaped. I'm just going to go outside in a minute just to check the skies, see if, because it's looking like we're getting a little bit of haze building up again. Because it's been a warm day today. There you go. Drop that back down to 250. I think 250 was the sweet spot. Yeah, we're picking up the Coma quite easily. Well, I say quite easily. A lot easier than we're picking up any of the solid mass. Right. Let me just reset this. There we go. There we go. There we go. Yeah, the sweet spot is a gain of 250 in about 45 seconds, 30 seconds to 45 seconds exposure. Let's go back to 45. I'm just going to nip outside and check the sky, see if it's hazy. I think it's going a bit hazy out there. There you go. Yeah, the camera's got a sweet spot. It's about 30 seconds with a gain of 250. And that's 45 seconds. But, now that's interesting. I don't know if you're picking up where I can see. Two elements again. One bit there, and one bit at the front. So that could possibly be the two main core fragments. I think we'll leave it on 45 and 250 and stick with this for a bit. Move this back out of the way. That's about as best as I can get it, I think. I think we'll stick with those settings. I'll make a note of that in my little notebook. 45 250. 30 250 is pretty good as well, but 45 seems to be quite happy with the slight haze we've got, because it is just slightly hazy out there. The first picture was a little bit better. Let's see if I can just tweak the settings to match. See, all I'm doing, we've got the basic data that comes in, and I'm just manipulating the histogram to highlight different intensities of pixels. Yeah, I can definitely see two distinct pieces. I might do a follow-up tomorrow and have a look at the Space Weather website, see if they've got any fresh pictures of it, and I'll grab one of those for comparison with these this evening. I mean, for a 12-inch telescope, a 300mm mirror, it's not doing too bad. But they've got a 90cm mirror. Mine's 30, so the light gathering capacity is significantly higher, and they've probably got a better camera than what I've got. So I'll be able to put a side-by-side comparison, and I'll know what to put on my birthday list for July. Just swing this out the way a bit. Yeah, very distinct core there, and a fragment there. Without zooming in, you can see it, but when you zoom in, you lose a little bit of it. One piece there, and another piece just there. A nebula. Right, I'll have a quick look what's close by, see what we can pick up. Bode's Galaxy should be within reason. That's got a bit of colour in it, although we're only using a mono camera. Couple of star clusters. What we got there? That's too low. Right, I'll see if I can find the Iris Nebula. See if that one can, I can pull that one out of the background. Yeah, it's still a distinct coma and a tail. As I thought earlier on, that I thought there were elements of debris. I think there were two background stars. Look. Yeah, one big piece there and one piece there. Two elements I can pick out from here. Right, just do a couple more exposures, then I'll see if I can pick out the Iris Nebula for you. It'd have been a lot better if I had a colour camera on, because you can pick out the blue hues a lot easier than you can with a mono camera. Although you'd be able to pick out a lot more nebulosity and infrared with this camera than a colour camera. So swings and roundabouts, you win and you lose. Right, it's a bit close to my horizons, but let's have a look, see if we've got a reference star nearby. Now we'll see. Right, I'll bring the stellarium across. Right, that's going to be the target. This is where we are at the moment. And we've drifted off a little bit. Either the telescope's drifting or stellarium accuracy is just a little bit off. So I'll just zoom back out again. And we'll see how accurate. If we've drifted off that far, we might not necessarily land on it straight away. Right. Right, current object, telescope, slew. There we go. If I zoom out a little bit, not moved, hang on. There we go. Right, let's move this away. Clear that. Go back to 15-second exposures. Yeah, I'm going to have lots of lines across here now. Yeah, the Hubble telescope, yeah, a lot of movement across there. Does have a mono camera, but it's got a filter wheel. So it can filter anything from infrared out to different elements. Right, I think that, do a 30-second exposure. There's a lot of wobble on the telescope after it's done a slew, so it needs to settle down a little bit. A bit of movement on scope. Right, let's have a look at that again. Right, just bear with me a second. I'm just going to find a reference star and walk it in. I'm just going to move off. Drop that back down to 5 seconds or less. 1 second will be good. Right, what I'm going to do, because I've slewed across, I've not done a proper alignment. I'm just going to find a reference star before dropping on the nebula. So I'm looking for a bright star coming up in the middle of the screen or somewhere on the screen. So we'll do a live 1/3 of a second exposure, and which is going to do a circular search. This is what you have to go through if you've not done all your alignments. And this evening I was being lazy and I didn't. What we're actually looking for to come across on the screen is a really bright star. It's a magnitude 3.2, so it should be brighter than a lot of the background stars. And with that drifting, with the scope drifting off the comet, I should imagine we're quite a way off target. So I might have to do a minute or two of circular searching to pick this star out. The lines indicate 1/3 of a second. That's the length of exposure. So the shutter's open for 1/3 of a second, and that's how far the scope travels in that time. There it was. I think it was down there. Let me just bring that back up again. So you have to have fast reactions just to take your finger off the button when the star comes into view, and then just centralise it. Right. Here we go. Too fast. That's the one, I think. That one there. Put the target up. What we're doing, we're aligning on this star here as a reference, and we're just going to walk across to the target, because this is the closest. If this is the right star, this is the closest one that's bright enough for a reference to the target for the next exposure. Synchronize. Right. Right, now it should be closer to the brighter core of the nebula we're going to look at. So somewhere in this area here, could be that star there. Oh, wait. Right, take that off. Right, there's going to be a bit of movement on there. Okay, Barrett, catch you again next time. Yeah, it's not that hard. Hang on, clear this. Once you get your hands on it yourself, I don't think we're going to see much nebulosity with a mono camera. But let's just see what we can pick out on the slightly longer exposure. Yeah, that small scope, it gives you a lot wider field of view with this particular camera. So it has its plus sides, and it's also a fast scope at f5. So you'll pick up the more fainter targets with slightly shorter exposures. Now, I'm not 100% convinced that that's our target star. It doesn't look like it. Right, in that case then, we'll just try something different. Finding a different reference star, and then we're going to pick on a slightly different target that should be easier to identify. There you go. That star there is Doobie. Let me just centralize that. So that could have been the right target. Let me just centralize this. The software only looks challenging when you don't get a chance to play with it. Once you've played with it for a while, it becomes a lot easier with familiarity. Right, I'll just show you where we are on Stellarium, and all this software is free. Right, that's the star that we're actually currently looking at. Doobie, that one there. So all I'm going to do is tell this to synchronize on that star. There we go. Now move that out of the way, and just below here is the Cigar Galaxy. Let's see how close we are on this one. Right, move that out of the way. Take the target off. And let's give it 10 seconds. I think we did this when we had the colour camera on. I'd look at it on that one. I can't actually see it on that screen. Just give it slightly longer exposure. Antares, well, that software that I use, Stellarium, if you type in your location on there, it will show you exactly what you can see if you look up at the sky. So that Stellarium software is really, really good. It helps you find your way about the sky. And what I'm doing, there it is. Right, there we go. No, we won't be far off. Right, that smudge there, when I get a little bit more centralised, is a galaxy from the edge, looking at it edgeways on. Right, clear that. Right then. There'll be still a little bit of movement on the scope because it's not settled yet. We've just come over for a big slew. And on screen you'll see the cigar galaxy. M82. Messier 82. There we go. I do a little stretch. Let's do a slightly longer exposure, because this is a faint galaxy. Well, I say faint. A few years ago, while I was setting up my observatory with the telescope and doing all the installations, 2 students found a supernova. I think it was somewhere in this region just here where the mouse pointer is. While they were talking to their tutor, they were setting up focus and stuff on their equipment, and they actually found a supernova in that one. And that was 2 days before I was even ready. Yeah, this one here is the cigar galaxy. I'll do bear with me a second. I'll centralise it. I'll get right in the centre. Drop the exposure back down again to manoeuvre it. And then I'll take you to M81. That's more of a spiral galaxy. But I just need to centralise this a little bit so we should have accurate movements. Yeah, that's close enough. Yeah, I'd have been over the moon if I was online that evening and found that. Let me just tweak the focus a little bit. Right. There we go. Now that's a lot better view of it. Now if I increase, let me just try stretch, see what it looks like with a stretch. Right, let's do a 30-second exposure on this. On this one, the central part of the galaxy is this area just here. And if you use a that's a bit of wind outside, it's a bit blustery. And if you use a hydrogen alpha filter, you can get tendrils of plasma emitting through the centre of the galaxy. And I've actually photographed it. It's on my other hard drive, unfortunately. It's not on this drive. And I did about 4 hours of worth of exposures on this target, and it really does look nice. Really does look nice. Yeah, there's just a little bit of wind outside at the moment. I just got to wait for it to die down. the second galaxy is just above this one, but I've got such a narrow field of vision with this camera. There we go, that's a lot better. Right, if I just stretch this a bit more, you can just about see, coming from here and just up here, gases, nebulosity. Let me just see if I can stretch it a bit more. You can just about, oh, bloody, excuse me swearing, wind. Because the main body of the telescope is so wide, it acts like a gigantic sail. Any breeze whatsoever catches it and blows it all over the place. There we go. Right, you can just about see it there, look. You see that gas erupting from this side here? You see it on that lot. Yes, you can just about see it there, but it's not looking brilliant. But yeah, there's gas erupting from the centre, and it is on that side there. But you need a different filter to get the clarity on that one. Right, let me there. Right, let me go. I'll show you where this is in comparison to the other galaxy. Just centralize that. Bring this stellarium across. Right, the scope's been blown off by the wind, so we're just slightly off. So let me just sync that on there. Right. Now if I select that target, and let the scope move across to that one. Yeah, we're doing such fine movements now. It won't necessarily know it's actually landed on the target till the exposure's finished. Right, I can't actually see it on that screen at the moment. Let it do a slightly longer exposure. Did it actually do a full swing? No, it didn't move right across. Right, leave that there for a second and see if it finds it. I can show you one that an image I took of this particular galaxy a while ago. I'm going to land on it in my collection. I don't know whereabouts that is now. Should be pretty central. Let me just go back to the right, I've just swung back to the original galaxy. Yeah, the wind's been an absolute pain. Seem to have lost everything. I'll have to make sure the bolts are tightened up so it's not slipping on the clutches. Right, it's gone 11 o'clock and I said I'd be finishing at 11 anyway. But anyway, we did see C2019 Y2 Atlas, and it is definitely, yeah, I'm way off target. I've got too much wind action on the tube, that's why we're off target. So yes, we did actually see the Comet, what was left of it this evening. It's a lot more, a lot less intense than what it was a couple of nights ago. So I'll try and do a stream tomorrow evening, and we'll see how it's progressing on intensity, see if it's still getting dimmer. You actually got some good pictures of it with a Nexstar 5 SE. That's awesome. That's awesome. What camera were you using? Yes, tomorrow evening. I shall be online from around 9 o'clock. I'll put a placeholder up, an announcement ready for the stream going live. A Sony camera. Ah, right. There's a bit of a delay between me reading your messages and it's actually coming up on my screen. So yeah, tomorrow evening, 9 o'clock. We'll start with Atlas, if I can see it again. And then we'll move on to something else if it's viable. So I'm going to call it an evening, get some shut-eye because I'm up early, very early in the morning. I'm going to say thank you everybody for joining me along this incredible journey. The Comet is fading. Let's just hope we can get another evening out of it before I lose it altogether. And the moon tour, that's in the planning stages. If there's anything you want to see, make a note and drop it in the discussion section of this cheers mate, on this YouTube channel, and we'll have a few hours having a wander around the moon. But for now, I'm going to say thank you to everybody for joining me. I shall see you all again tomorrow evening if you care to join in. And don't forget, if you like what you see, hit that like button and please subscribe for more. Let me know you like it and we'll carry on regardless. Thanks Chris, thanks Pianist, Tom, if you're still there. Barra, nice to see you again. And I'll catch everybody again soon. Thanks very much and have a nice evening.